Hey, that was pretty good, not bad.
I would like to brag. I'm pretty good at this thing.
You're pretty good at that intro thing. Yes, you have permanent responsibilities for it now though. See what you have done.
No.
Love it. Up. Um Good afternoon, GitOpsians. Welcome to episode 62. Wow. We're really at 62 now. Yeah. So this week's episode is on DORA metrics, which are DevOps metrics, and Polaris, which is a very neat tool that originally came out of the Konveyor project on gathering and measuring those. But real quick, first, before we begin with that, a couple minor announcements. The first one is that ArgoCon North America, which is co-located with KubeCon in Chicago this October. Yeah, something like that. The CFPs for that close on August 6th. So that's coming up in a couple short weeks here. So get those CFPs in. We always like to watch those videos and figure out what people are really doing with Argo. Other minor announcement is that I am leaving on vacation next week and I will be out for 2 weeks. Therefore, the next GitOps Guide to the Galaxy stream will be sometime in August, second week of August, I think, instead of last week of July. So we're skipping the stream in 2 weeks. I will be on vacation and celebrating my birthday instead. You may send me birthday wishes over Twitter as per usual. I also accepting messenger pigeons and LinkedIn messages and any other ways of telling me that you're celebrating my birthday. So because it's the best holiday. That's it. That's all I had for the announcements. Johnny, you didn't have anything, right?
No, not that I can think of.
Perfect. Okay, so then we'll get started. I will introduce Wes now and Michal, who are the two of the brains behind Polaris. We'll put it that way. And Wes, I'll let you introduce yourself and pass the baton.
All right. I get a full brain. Thank you for the compliment. Wes Hayutin, been at Red Hat for around 16 years, engineering manager for Polaris, the community project.
And hello, good afternoon, good morning, wherever you are. So my name is Michal, and I've been engineering, working for Red Hat, working for Pelorus project, contributing to it, having fun with it. So I hope you will enjoy today's show and demo of this project. Thank you.
That was really fast intros, guys. But you're good. Good for you. Good for you. They obviously don't like to talk about themselves. You're not going to be a streaming host anytime soon. We have to be real good at talking about ourselves, right, Johnny?
That's right.
That's right. Anyway, so I know that you have some slides for us, a demo for us. Wes, I think your slides are up first.
Yes.
Perfect. Let's hit.
All right. So I do like talking about Polaris and naming software projects. We all know is the hardest thing in the world. Why would we name this particular project Polaris? Traditionally, before we became so famous, Polaris was known as a navigational instrument used on ships to help determine what the ship's bearing is. Think of it as like a simplified compass without a true north. We hope that Polaris, the software engineering project, also isn't going to tell you exactly where to go, but help align your organization to where you want to go and keeping you on track while you compare your organization to that bearing that you've set. So that's how we came up with the name.
That is a much more thoughtful name than some other ways I've seen things named. So I'm going to say that works pretty well.
Yeah. We are filled with thoughtful people.
That means I'm getting a really awesome birthday card, right? That's what thoughtful people do.
I register that and noted. All right, let me attempt to get to the next slide. Okay, so we've established what the name is, and so how do we help software organizations find their bearing. We are collecting metrics from various traditional sources, your SCM, your issue tracker, from OpenShift directly, bringing those metrics together in a dashboard that hopefully is fairly easy for organizations to read, so they can start having conversations about how they want to steer their organization improvement to the bearing that they want to set. The dashboarding and the information you get from Pelorus will help your organization or any organization realize what kind of business value they're getting from various changes, processes, procedures that they are implementing in their organization or that they already have established. Compare those against various teams in your organization, or as an aggregate as well. You can see all your organizations together to see what kind of business value you're getting out of your changes, and to make corrections, see who's doing something well, see who's doing something poorly, compare, contrast, get on the right bearing. All right, so this is just a small sliver of what Pelorus looks like. Fairly easy to install. We're in the community operators for OpenShift. Installing and getting some sample data. We've done it, we've timed it, takes about 5 minutes. So hopefully folks in the community also find it easy to get it up and running, get some sample data in there, get a feel for how things work. Okay, so basically, as we're collecting information on various teams and their software delivery performance, we'll get to that in a moment, it just really boils down to a classic science experiment. You take your control, you measure that, you introduce some change, some experiment, you measure that, compare and contrast, repeat, rinse and repeat over and over, again, trying to constantly improve, which everyone in the software industry is always trying to just do things a little bit better every day. Not everyone is measuring those changes. So what we're trying to avoid. Does it feel like we're getting better? Sure, it feels like we're getting better. People are saying we're getting better. That kind of boils down to gut checks. We're trying to help organizations avoid the gut check and actually have real metrics to understand if their changes are having any real meaningful impact.
So I'm actually going to interrupt you here because some context that I think you and I share, Wes, that other people might not. And I actually was on Tuesday, I participated in a Dynatrace panel for the state of SRE. And they asked me the question, which was like, what is the most surprising thing that you've experienced in the last year in your SRE practices? And so recently, having come from a position of trying to help advance SRE culture across the broader like Red Hat organization, what I found was that teams were doing a lot, but with very little data. And with very little way of understanding and contextualizing the data that they did have. So I kind of, and it's not like Red Hat we're not unique to this position, right? I've talked to people all across the industry. It's basically been the case of people are doing a lot with gut checks and kind of general, and not having necessarily great like hard data to really know how their perception is comparing against reality. So like my favorite metric here is actually change failure rate, excuse me. That's the dyslexia happening right there. The change failure rate probably is my favorite of the DORA metrics, because that is like that one is a data, but it's also kind of a gut check. Like, I think we're getting better. And like there's okay, that can actually aim towards like, oh yeah, we are. Now, if you're getting better because you're deploying a lot less frequently than you were before, maybe you're not really getting better. And that's, that's a whole other, soul searching thing you have to do as an organization. But so that's why I really like this project. It's why I asked you guys to come here and talk about this, is because holistically across the industry, I think where a lot of us are still from like an SRE perspective, where we're fighting fires, we're still like, we're not really looking at preventative stuff as much as we would want yet. And it's hard to make good, as you say, like bearing directional decisions without the data. So I want to like kind of reemphasize, people are doing a lot of really awesome things without data, and this solves that problem. Back to you.
Yeah, I've had the same experience. Some of these gut checks will come out at the end of a release during a retrospective, and and if you have a pretty, like, some of the best organizations I've seen do bring some data to that kind of a retrospective, but what I have not seen is across a large organization being able to break down application or team by team, being able to understand who's doing some things particularly well and who's not, and what we can learn from each other in that way. And that doesn't come out from gut checks, because people aren't going to call out other teams that way publicly, and that's just not the way it works. But if we're all unbiasedly bringing in data from our processes and then have them up for the world to see, and with good intentions, raising those problems up, or demonstrating who's good, who's bad, with the intention of correcting that bearing back to, oh, I can learn something from this team over here, then I think this product helps.
It's black and white, right? That's what you do. You're bringing binary decisions to the table. You've got legitimate content, right? It's objective. It's not like,
it's objective.
Okay,
That's the key.
I've got this gut feeling that it's your team doing this. It's like, no, I've got data that backs this up. You are introducing a regression quarterly, and like it's causing this thing. So it's tangible data that you can use, to make a difference and essentially get better. So yeah. That's awesome.
Yeah, well said. Okay, so overall, what we're measuring is software delivery performance, and we're measuring that overall with the 4 key DORA metrics: lead time to change, deployment frequency, mean time to restore, and change failure rate. And we'll get into a better definition of what those things are. We also, if this is starting to sound compelling to you or your organization, you can deep dive. And some good books to check out, especially, are Accelerate, and I like Lean Thinking as well. So if this is starting to sound like something you need to have for your organization, I highly recommend reading these books here, especially those two. Today, we're going to go kind of Cliff Note edition. Never fully recommended, but here we go. So what are those 4 key DORA metrics? What do they mean? We'll start with lead time for change on the left. And this is kind of a measure of your market agility. You want a low lead time for change, which is the time your software engineer committed the code to when it was actually put in a production build. So small changes, small features getting out to customers, bug fixes coming in often. This is kind of what you want to see. You don't want to see the monolithic, huge release, overwhelm your customers, introduce a lot of new bugs all at once. That's not the ideal, according to some of the reading that I previously mentioned. Same thing with the deployment frequency. I have a lawnmower here. Just one moment, please. Never know when that's going to happen.
It wasn't bad, I promise.
Someone called to make that happen. I'm sure.
It was totally not me, But if I had thought of it, I absolutely would have done that. That
It's
would have
part
been
of being
amazing.
thoughtful is to play
It's part
practical
of being
jokes on your
thoughtful.
friends. Like-
Yes, exactly. That's how you're a thoughtful friend shows they care by giving their other friend just a little bit of a hard time.
Right. Okay, so moving on to deployment frequency. Again, an indicator of small batch size. You want to have lots of deployments getting out to production, small, making sure that you have your, the more often you're doing it, the better you are at it. And the easier it is to consume for your customers.
Can I just make a? I'm sorry. Can I just like jump
Sure,
in really
jump
quick?
in.
And I just want to give an example of this, right? Like there's within our team, like we do validated patterns and stuff like that. There's one time I had this huge commit, right? And it had like 400 commits. Like it was ridiculous. It was massive. It was large, and at the end of the day, right, I got my hand slapped because it's like, dude, nobody can actually go back and review that, right? And I think that kind of ties in a lot of this. You want these small bite-sized changes so that way, like, hey, I can actually do a code review, push it out, and then get it out into production, and just do these little bite-sized config changes. Because the big, massive ones, they're just a pain for your team. You're basically screwing your friends over, and it's not that fun. So.
That's not how we're a thoughtful friend.
That's not being a thoughtful friend. Yeah, that's being a bad friend, and that's I was a bad friend once. So sorry, I just want to jump in with that.
I was gonna say the other thing is especially when your customers are other software engineers, right? Especially when your customers are other software engineers, just like big jumping, just like big bucket size changes on them is just, I mean, how many things have I seen gone wrong because a dependency dropped just a bucket of changes and something was missed because the change log was too big to truly, for one person to truly consume and comprehend, right? Happens all the time. So it's how you're a good friend to your friends and coworkers. It's how you're a good vendor to your customers.
It's a good idea to think of your customers as friends. You'll probably do better for them.
Yeah, probably be a little bit better for that. I think for one of the fun things about, although we have a lot of Red Hatters who watch this stream and participate in the chat, we do actually have quite a few customers who watch this stream and occasionally make it to participate in the chat too. So we actually get to live that our customers are our friends here in GitOps Guide. So that's kind of a cute little that's very true life, at least for me. Our customers are my friends. Hi guys.
Hi friends.
Hi friends.
So the small size, I think also comes into small batch size, frequent deployments comes into the far right change failure rate, your favorite metric, Hillary, in case you have to roll back. If you have to roll back a huge monolithic change, oh, the pain. You might be rolling back a feature that some other customer needs. Not okay. So what is change failure rate? It's the percentage of deployments overall or in a certain time period that you had to roll back to fix. And so obviously you want to keep that as small as possible. And in worst case scenario, if you do have to do it, the small batch size really helps. Mean time to restore is a little bit easier to understand now. It's just simply how long it took once you did roll back. You opened up a bug, rolled back. How long did it take to get a fix in, push it out to production, verify it, close the bug? And that's
we're actually sorry. I'll say we're actually using this in a second way here in the SRE practice at Red Hat. Is we're also tracking this for how long it takes us to resolve incidents, regardless of if that incident is fixed by a push to production or by a manual intervention. Because we're also using mean time to restore to track how we're doing with our error budgets and our SLOs, which is a complete, not really part of the intent of the metric, I don't think. But it's one of the ways we started applying the metric because it helps us to understand cost in a way of not just like the dollars spent on cloud compute, but also the dollars spent on person time and effort.
Yeah, I could see the same thing being opened up if there was a network outage or something like that and your service was down and if you wanted to track that, absolutely. I think that's totally appropriate. All right. So we know what the 4 metrics are vaguely, Cliff Notes style. What do software organizations do that impact these 4 things? And this is where I kind of start going crazy. So calm me down a little bit if you need to. So in every software organization I've ever worked in, all of these things on this slide that I have under each metric are done a little bit different. They're also done a little bit differently um, each week, each month. Let's use engineer engagement as an example. Are the engineers on your team highly motivated, come running to their keyboards in the morning, drinking coffee, banging out features and bug fixes? Or is it like coming up to a holiday? Is it almost Christmas and everyone's burnt out and just needs to get away? That happens on every team. It's kind of like measuring when you take your car to the dealership. You never want to get your car worked on a Friday, because the folks working there are not thinking about your car. They're thinking about the weekend, and you don't want to get it done. This engineer engagement is a variable, even across the best of teams, across time, and very different across personnel, obviously. So it would be really neat if we could kind of see that through the lead time for change. Same thing with code reviews. How well are your engineers reviewing the code? Are they actually finding bugs while in code review, correcting things, making things better? Or just slapping on "looks good to me" and let's go, let's get this release out the door. It's Friday, we got a weekend.
Ship it.
Is it easy for them to find bugs themselves with automated unit tests, integration tests? And is that running through CI? And is your CI fast feedback, or do you have to put in your patch and then come back in the next day and read the results when you're out of context and you need to get back into flow state? All these things are variable across every team I've been on, and almost variable from week to week, month to month, year to year, depending on who's on your team and how they're feeling. Any questions on lead time for change?
So I'm not sure how much of a real question it is, because I do know Tal, which is code review relevant at all? And feel free, Tal, to, because I don't know if you actually expected me to address this, feel free to clarify the question. Is code review relevant at all? And that is a really, I don't even know how to take that question. It's an interesting thought experiment. I will say something I've seen done well. Some of the teams at Red Hat have somebody who's sort of like almost on call to do the code reviews for a period of time, right? And then like that changes. Whoever's supposed to do the code review will like alternate through a rotation to help kind of reduce like code review burnout. And the people who are doing the code reviews are not necessarily expected to do feature work during that period of time, so that they're not context shifting too much and compromising the integrity of the review.
I think code reviews are an opportunity for more experienced senior engineers to help grow new engineers with their patches. As long as everyone is doing it with good intentions and nice and trying to help folks out, code reviews are an amazing learning opportunity for everyone. It's also something that I've recently thought that maybe a first pass with AI would be a good thing to hook in your PRs to automatically have whatever AI agent you want to do an initial review for you, get the easy stuff out of the way, boilerplate kind of stuff, and then let the more meaningful code review come from senior engineers.
I also think that code reviews are important here because they may affect change failure rate at some point, because the less reviews, the less eyes on the code, then the higher change failure rate maybe, right?
Yeah, it's a team skill.
Engagement. Yeah,
I've seen there's a big variance in code reviews. I've seen it done really well, where you're not only looking at the code, you're pulling the patch, you're trying it out, you're really giving that feedback. It's going to be something that everyone's experience is a little bit different.
And the
can be done.
team synergy grows then when there is a code review, because people talk to each other even through that channel rather than face to face, right? Still, there is some communication established.
Yeah. Okay.
I think we could wax poetical on code reviews. I know Tal has some opinions that we can see in the chat here about like it delays lead time to change. Sure. Well, let's some other time we could do an entire episode just on code reviews, but let's continue on now.
Right. Well, I mean, to this point, an example would be, let's say there's a team that has a high lead for change, but a very low change failure rate. Maybe that difference is all in the quality of the code reviews. Don't know, but wouldn't know unless you measured it. Moving on to deployment frequency, some really cool new stuff out in the industry, GitOps, Argo, MLOps, to help you get your code from GitHub to production, all automated, all very cool stuff will help your deployment frequency go up. If you're not cutting edge, if you don't have those things, something as basic as when when I used to help deploy, let's see, was satellite hosted back in the day. All we had was checklists. This is a long time ago. When I get wheeled into the emergency room to have my leg cut off, and I look down at my leg and the correct leg has the mark on it for that one to be cut off, I would be very happy and more confident. I'm kind of paranoid about that. But checklists, surgeons use them, pilots use them. If that's all you got, use it. Security scans, improved change management, all those kinds of things help your deployment frequency go up, and vary greatly from team to team. I'm going to keep re-emphasizing that because we want to learn from each other, experiment in teams, take best practices. That's your bearing. That's what Polaris will help you find. Flipping over to change failure rate, again on the far right, these are the percentage of bugs found in production. Are you doing deep planning, designing, looking for edge cases while you're in design? Are your test environments like your production environments? Are you having retrospectives? Are you implementing do not repeat yourself when it comes to errors? All those things vary from team to team and also help reduce your change failure rate. Mean time to restore, same kind of thing. What's your rollback strategy? Do you have a backup of your production instance? Can you just take the last known good or n-1 and send it out instantly? Do you have failover across regions? Maybe you can do it that way. But getting from outage to back to running as quickly as possible varies from product to product, and is key for customer success.
There was an article I was shown recently. This goes back to we'd have to determine what kind of impact our code reviews have by determining some way of measuring them. There was an article I read, and I'd have to find it again, so I will have to tweet this out later because my colleague sent it to me. And it basically said that a DORA metric is anything that you can measure in a meaningful way for your team. So we have these like kind of 4 key ones that they've come up with, and kind of they left the door open for DORA metrics could be these 4 plus additional really important metrics to your team and your organization. And so as we look at kind of like the things within these things, like I'm sure there's room for other metrics to be invented in a way that helps your team, your organization find its bearing. Everywhere I've worked, every team I have worked on, we have worked differently, but have worked in a way that worked for the team. Right. So I think that's really important kind of with that whole like conversation about no true north, just bearing. Yeah. I think that's kind of an important context. For a lot of folks who watch this stream have been in the industry a long time and have that same shared experience, but some folks are newer to the industry and won't have that perspective. So I think that's just a kind of, I'd like to call it out as meaningful here.
Yeah. We've discussed probably every team that uses Pelorus will have unique needs. And I think Michal will kind of touch on that in some of those upcoming slides.
I hope so.
Is that my cue to flip over to his screen share?
In the most thoughtful way possible.
Wow, that was really subtle. I'm not good at subtlety. Here we go.
Okay. So far, Wes, thank you for your slides and for explaining the DORA metrics here. And in this part of the presentation, we'll focus on how the Pelorus is measuring those metrics. And to start with, we need to first better understand the definition of what exporter is. And then we'll go to the architecture of Pelorus, each of the exporter definitions, what it captures, how it then translates to those DORA metrics. So Pelorus is an operator at the currently a community operator, as was explained in the first slide, available in OpenShift Marketplace. We had open a ticket to make it also working for Kubernetes native. We don't know when or if this will happen, but at the moment it's fitted to monitor OpenShift workload. And it's installing a couple of components. On the right side of the slide, you can see that it installs Prometheus, Grafana, and this is a simplified example because later we'll go to the a bit more interesting example architecture with exporters. So exporters is a Prometheus concept. It's not something that Pelorus invited. It's a Prometheus concept to gather some data from different APIs, from different services, and then expose this data through a simple HTTP or HTTPS endpoint. And then Prometheus scrapes this data. So it goes to that endpoint, and every while it just looks for the data there, and then it stores in its own database for visualization and some rules. On top of that, Pelorus also inside Prometheus and Grafana installs or sets some of the rules. And this is the secret sauce of Pelorus as well, because those rules are then being visible for us through the UI. So we build those exporters on top of already existing Prometheus framework, and we integrate with Prometheus directly there. Pelorus currently have 3 main types of the exporters. We can see commit time, deploy time, failure, and as we go through those slides, we will understand what each of the functions of this exporter is doing and why. There was also a new exporter introduced, webhook, and this is do it all for us. So basically, webhook can serve as any type of exporter, plus some extra types that can be, as Wes said, some teams, some organizations have special requests. So webhook also allows us to add those special needs to it. It's pluggable architecture, just a Python code that allows us to gather more information than just those 3 metrics currently do. Okay, so this is a very simplistic diagram to show what I already have said. And we can see those 3 exporters, commit time, failure time, and deploy time, that are pulling the information from event data sources. So this is a pull method. We connect to different APIs, to different services, and then pull this data. And then our Prometheus instance, which is also deployed as part of the Pelorus operator, is pulling data from those exporters. On the right side, there is this webhook exporter. So webhook exporter acts as a kind of proxy to the Prometheus. We push the data to it from any source. So this can integrate easily with third-party CI systems and some failure tracking systems. And we have a well-established structure of the data that needs to be sent to that webhook. And this will then expose this data to the Prometheus instance. So instead of relying on some of the APIs, we just enabled everything to the entire world. And this is how, for example, 4Keys project was working by allowing only the webhook exporter to be used. Okay, so now a bit about exporters. The commit time exporter is the one that connects the commit hash together with the image SHA. So we are building container with some image, with some SHA available for us that was created from a particular commit in the Git repository or any SCM repository, to be honest here. If we are using webhook, then we can use any repository here. And then this information is being combined together to one metric, which consists of information such as what application we are deploying, what commit hash is there, what image SHA was used to deploy that application, and then the namespace where this application was deployed, and a timestamp when this event happened. So having this information, we can either use on the this webhook exporter, or we can automatically query some of the APIs. And Pelorus supports from the Git endpoints, GitHub, Bitbucket, GitIA, GitLab, Azure DevOps. Also, it supports the image stream in OpenShift. So OpenShift have concepts of the internal registry, and the objects there, image streams, can be annotated, labeled, and then we can take advantage of this by taking this information, the commit information from those objects, and then translating to Prometheus metrics. And also recently a container image also was added. So this is similar to image stream. However, it does a bit more. It goes to the container registry such as Quay or Docker.io, and then uses Scopio to query for the labels that were embedded in the container itself. This goes outside of OpenShift objects and APIs, and it allows developers to embed this information directly to the container image. Then we have a failure exporter, and the failure exporter is capturing the timestamp at which the failure in a production occurred and it was resolved. Why in production? Because, for example, we can measure, we can store our failures in Jira, but not all of the failures there are production one. From the DORA perspective, we are really interested in the ones that are affecting our deployments on a production. So somehow we need to filter out from all the Jira tickets, from all the Jira cards, the ones that are actually causing the failure on the production. And every deployment, every group, every organization may use a different layout of Jira cards, of Jira labels. That's why we have our own defaults. Plus, we have included a custom query. So really, anyone can adjust this failure exporter to its own Jira workflow based on a well-known Jira queries. Also, this failure exporter allows us to query APIs from the GitHub issues, ServiceNow, PagerDuty, Azure DevOps, and Webhook, because Webhook, as we said, is a push data model that serves it all. And then the deploy time exporter, which captures the timestamp at which the deployment happened in a production environment. Also, an application can be deployed to a staging environment or to some testing environment, some other namespace, but we are really interested in the ones that are deployed to a production. And the configuration of each of those exporters allow us to really fit the user needs. So it's really important to understand how we are deploying application, how we are building application, to make sure that Pelorus will gather the events that are really interesting and really the ones that are affecting production and not the staging. And there are many different configuration options, and the first homework that anyone should do trying to adapt Pelorus to be useful is actually to see how the end-to-end application lifecycle, application pipeline is done, and then adapt those exporters to fit those application pipelines. Okay. Now, this is a bit bigger architecture for Pelorus. So as any environment, we may have multiple clusters. We rely on Prometheus, and Prometheus also works pretty well with things like Thanos. Thanos is not on this diagram to not pollute this diagram, but this diagram is to present that we may have multiple clusters with one Pelorus instance per cluster, and then for that particular cluster, we may have those exporters that are serving the needs for a particular cluster or particular application living in that cluster. We also, on the left side, can connect this Pelorus instance, there were some tries like that, to any external Prometheus exporter, because this is, as I said, the Prometheus. Sorry, Hilar, if there is any questions, please stop me, because I am just looking at the slides and I don't see any questions.
No, we have no questions so far. Don't worry, I would have interrupted you.
Okay, thank you. Yeah, I don't see your faces or anything that happens on the chat, so if there's anything, just ping here. Okay, and on the left side, we can see also external Prometheus exporter, because maybe there is another instance running somewhere else of the cluster. So we also allow this to do to customize the deployment of the Pelorus, and also connect everything through the S3 storage to ensure that if the cluster goes off or there is a redeployment in another cluster, this data is not lost. Why? Because the data for the DORA metrics is the most important for us. Really, the purpose of the Pelorus is to store the data for longer period of time. It's pretty hard to actually show this demo because we store the data for 1 to 3 days. But the real value of this tool is to monitor the deployments, monitor the commits across months. So we can see what happens in different projects, in different applications across a longer period of time. So that's why it's very important to also use this persistent storage and back it up with some S3 storage. So it can be then used later on in another, let's say, Pelorus instance, or connect to a bigger set of instances of Pelorus. This slide is to show this Pelorus dashboard. We use, so let's go back actually. We use here on the in the top left corner Grafana. So Grafana is also, we use community operator to deploy Grafana that points to either Prometheus directly, or if we are using the S3 storage to a Thanos query, to aggregate this data from multiple clusters. And then Grafana allows us to represent this data in those 4 nice, simple views. And this is the view of Pelorus, and that provides
it's the aggregate
of all the information. Yes, thank you, Wes. Sometimes I need to drink something to get my tongue. Right. So how the Pelorus collects this data is one thing. So we know that it connects to different APIs. It stores the information from the OpenShift object itself. We can push the data to those exporters. But also we need to, I think, understand how this lives in the application pipeline. So in a good DevOps environment, we have, and I just split those phases into some simple blocks. We have continuous integration. So this is everything that happens before pushing some code to the delivery phase. So there are happening some builds, some tests, some small CI is happening, and the best is if it's all automated. Of course, writing code cannot be yet automated, but we don't know. In a couple of years from now, maybe it will be easier to write a code. But here we just capture the point where the code was reviewed or not. Some of us doesn't like reviews, that's okay. But if for some that does, the code needs to go through some cycles, and then it's committed to the repository, to some main source from which the application is being built. So we take this code artifact, and then we move it to the production phase. And from that point, we know that the code was committed at some point of time. And this is the first point where Pelorus is interested in. And this is this commit time. And the commit may have happened like even a year prior to the build time. However, the Pelorus, as we know, is the direction. It's not the tool to go back in the history. So we are really interested in the events that happens from the time that the Pelorus was deployed. So even if we do gather this data from the past, sometimes we just ignore this data. So the next part is this production phase, where we build the source code. We test it again and again and again. I hope that the testing phase is good enough to not introduce problems. And then we create some artifact. It can be a container image, it can be just a tarball, it can be just a source code stored in the Git repository, because, for example, OpenShift allows to build the application from source to image. And then the artifact is just the code itself. And then this artifact is sent for staging environment, testing environment, maybe some third environment, we don't know, but at the end, it's good to have it in production. So this is the point where Pelorus is looking at second event and looking, okay, when this application actually landed in the deployment. And going back, in the slides, we could actually see that this deploy to the production is taken from the OpenShift workload. So this is one point where Pelorus can look at the replica sets, pods, and then combine this information together and say, okay, my application is deployed. When was the commit time? The commit was on the first, when the first event occurred. And based on that, we can calculate some of the DORA metrics. And then our application is working, and of course, bugs happens, because why not? And application fails because bugs can cause production failures, and we are interested in those events. The application failed, so we are checking when the application failed. The entire application pipeline can start from the beginning, because there needs to be fix, there needs to be an artifact, there needs to be a delivery phase, and a new production ready application. And then when the application is fixed, we see the second phase of the third data point event that the application is working again. And this is our failure exporter that does the third step. Hope this is understood. And now let's focus a bit on the 4 metrics from the exporter
So
point of view.
just a quick time check, because we've got about 10 minutes to go. And I know that you did have a demo, I think, that you wanted to do. So I don't know if you...
Okay, so I will be fast, and the demo will occupy no more than 3 minutes, and this will take around 5 more, maybe 3. Let's see. So tell me when it will be like minutes. Exporter to take time, and then in the time interval for the so we can say time is also time through the Grafana. Change failure rate, also something that was explained in the at the beginning, is also very simple calculation. Is a number of failed changes divided by the total number of changes to the system. So under the hood, the secret sauce and the Prometheus rules are a bit more complex than just this, but we don't need to go there. Just number of failed changes, and the total number of changes to the system can be many things here. But if someone is interested, the rules are in the source code, so it's pretty easy to find. And then the last one is the mean time to restore, which is the failure exporter. So how long does it take to restore service on a production when a service incident occurred? And this is the average time over a period of time, because we can say, again, this happened like within 1 month, 2 months time frame, and our average was 20 minutes to restore a production failure. And this also can be applied to one particular application, or across group, or across all the applications that we are monitoring. Okay, so sorry, I moved back. We have in our source code, which is here, a demo. So sorry, a demo where everyone can go and quickly run the demo against OpenShift environment. And this demo will deploy a Tekton pipeline, build some simple application using source to image or binary build, then also label everything for the Pelorus to monitor properly. And this demo will give us a pretty nice feeling of how Pelorus works. For today, I created a slightly different environment where I was using the webhook exporter to send the data, and I created 3 applications: GitOps Guide to the Galaxy, then the second application, the Galaxy application, and the third application, which is actually called here the second sample application. And we can see here the Grafana dashboard. We can select a different time slot. This is something that Grafana provides. And we can see here those 4 DORA metrics. So lead time to change, we can see that here the average within those 6 hours was 6.7 minutes. I hope that everyone understands now what is the lead time for change. The deployment frequency. So we got 23 deployments over this period of time, and we got a couple of bugs, failures on the production. You can see here is also a very short lived failure. So we have 1, 2, 3, 4, 5 failures, and we can see that over the 23 deployments, there were 5 failures, and over this time, there is an 8.6 minutes interval to fix it. Yep.
And one of the things I really like about this view for organizations, coming back to kind of like your bearing, is obviously we haven't been running this particular instance for like a year or two, but really the value of this having running for that long is where are we now? Where were we 3 months ago and 6 months ago? And let's compare those, or even like a year ago. Time enough for these organizational changes to kind of work their way in, kind of like raising interest rates. It takes a while for the effect to be read in. That's where I think on a day-to-day basis, this isn't going to be the most useful information because change doesn't happen that quickly. But really being able to see like a diary or a log from a year ago where you were in your organization, this proves to be extremely valuable, I think.
Exactly, and we can see also here that, for example, for this particular application, the change failure rate was lower. So we had some problems on the production here happen, but overall, we were getting better and better.
I think it's also really important to, when you look at these metrics, there's something in the actual, like the DORA DevOps research. It's like kind of like these concepts of DORA High and DORA Elite and so forth. And I think rightfully so, those get a lot of pushback because, you know, if you slow down your deployment frequency slightly, and maybe you drop out of DORA Elite to DORA High, but your change rate failure also drastically dropped off and is like almost 0%, right? That probably was the right decision for your organization. So I like that, you know, you're not opinionating in any way the data that you're displaying. It's just the data is the data, and people will do with it what makes sense for them.
Right, and it's also good because it's kind of conversation point for them, right? Why this happened? What we can do to make it better? So this is important for the team.
There aren't any managers across any organization that I've ever seen, at least, that can look at 10 different teams, know in depth their processes and procedures, and be able to articulate why A is better than B with data. It would be nice, though.
Wouldn't it be nice? I think there's a song, right? Wouldn't it be nice? Let's not sing it, but I want it in everybody's head now.
Here's your earworm for the day.
Earworm for the day. You're welcome. This is what thoughtful people do.
That's right.
Okay, so to finish this presentation, I'd like to point to our documentation. It's under dora-metrics.io, and we put a lot of effort to make it readable and pretty clean. You have a quick start installation tutorial, a long configuration list, because as I said, it's important to understand the process and adopt those exporters to your needs. And we made quite a nice way of for contributors to easy their first steps in the Pelorus projects. Basically, everything is done through the make file. Make.dev will prepare everything for you to start playing with it, to deploying it, to running CI tests locally, and it's pretty easy to do that. So, thank you.
I love a good make file. Fantastic.
Also, actually, Wes added a pretty nice thing which is called make help, which is unique here. So it will print everything what make which make will do for you.
Yeah.
What does it make help just launched an instance of ChatGPT? Like, what does it do?
that's in the next version.
Next level, yeah.
Oh man. Okay, that's great. That's fantastic. Okay, well, that timing was perfect. We are exactly at top of the hour. Thank you so much for coming here and talking to everybody about these concepts and showing us the demo. I really appreciate it. I don't have any closing thoughts. I don't see anything in the chat. So if you snooze, you lose. Just tweet me questions later, and I'll relay them through the Slack ether to get the answers. Should you so desire. And I think is there a public community actually around Pelorus where people can interface with the team? GitHub issues?
Yeah, GitHub GitHub's the best way to do it. There's the GitHub discussion and issues. Discussion's probably key. Yeah.
Yeah, perfect. So if you can find them, these folks on the discussion on the GitHub project, which I linked it somewhere. Here it is. I'll show it. There you go. Pause your screen. Copy the comment from the YouTube interface. However you do it. We will let these guys go. We are going to. I will hit end stream. I will remind everybody, as per usual, to choose your technical debt wisely. And I will see you in roughly 4 weeks. 4 weeks, not 2 weeks. I'm going on vacation. Bye-bye.
Bye-bye.
Enjoy.